what I've said yesterday. I want you guys to review the slide 1 to 40. So do you guys have any questions so far? So this is now the time for the consultation regarding with those slides. Anyone who has a question from slide 1 to slide 40? None? So is everything clear so far from slide 1 to slide 40? Hello guys, any feedback? Just want to know if you guys were able to understand our discussion last meeting. I mean, yesterday. Hello? Guys, dyan na ba kayo?
Yes, sir. Nandito pa.
Diyan pa. Okay. So, okay ba kayo sa slide 1 to 40? Is there a part that we need to go back once again so that we can, just discuss it one more time for you guys to be able to understand it a little bit better?
So far, wala naman, sir.
Okay, how about the others? Mr. Charles, Mr. Antero, I don't know, Antero or Miss or Mr. Miss Crystalline, Mr. Christian Ray, Miss Rubis, Mr. Mark Allen, Mr. Tuliorta, Mr. Alores, Jairus, Eliza, Brian, sure? Bahala kayo. This is now your chance to, ask anything. Anyway, so if you guys do not have a question anymore regarding with the topics yesterday, so let's now continue our discussion. So are you guys ready now to talk about operations and numbers?
Yes, sir.
All right. Okay then, so let us start with binary addition. So binary addition is very simple, okay? So it is same rule as decimal, okay? So as you guys can see right here, 1 plus 1 is 10, 1 plus 1 plus 1 is 11, and then 1 plus 1 plus 1 plus 1 is 100, okay? So how did we get those 100, 11, and then 10? So you can say that it came from this table. All right, so we do have this table for addition. So 1 plus 0 is 1. All right, so no problem with that. And 0 plus 0 is 0. No problem also. 0 plus 1 is 1. So there's also no problem. It's very common with our mathematics. However, once we have this 1 plus 1, it is equal to 10. So is there anyone who has an idea on how did we get 10? All right, so I guess none. So here's what happened, okay? If you're going to think about it, this one is binary addition, right? And when we say binary, there's only two numbers or two characters in binary, which is 0 and 1. But in here, yeah, like if we are adding a 1 plus 1 in natural way, this 1 should be equal to 2, right? It's only logical that you will get 2. But since this is in binary, then you have to represent this decimal into binary also. Okay, so going back to our 4-bit binary, so we have 4-bit, right? So the first one, or the lowest bit, has a value of 1. The second one has a value of 2. The third one is 4. And then the last one is 8. Okay, so if you're going to represent the 2 in binary, so it should be 0, 0, 1, 0. Correct? And as you can see right here, you can actually remove this one. Okay, it won't affect the result of your binary combination. Okay, so you can just simply write 10. So that is why 1 plus 1 is equal to 10, but not 2. Okay, since we are adding in binary. Okay, so it should be represented by binary. All right, so are we clear so far on how did we get 10?
Yes, sir.
Okay, but how about 1 plus 1 plus 1 plus 1? We have 3 ones. We have here a result of 11. So again, 1 plus 1 plus 1 in decimal, this one is equal to 3. But then again, this decimal should be converted into binary, okay, which is represented by 0 and 1s only. So going back here, if you're going to form 3, then you have to activate the 2 and 1. So it should be 0, 1, 1. So again, you can remove this one. It will not affect your answer. So you can just simply write 11. So are we clear with how did we get this 11 or 1, 1? Hello? Hello, guys. Are we clear with 1 plus 1 plus 1?
Yes, sir.
Yes, sir.
Tutulog pa yata kayo eh. Anyway, so how about if we have 4 ones? 1 plus 1 plus 1 plus 1. So in decimal, this could be represented into equal to 4. Then again, we have to represent this 4 in binary. Okay, so it must be in 4-bit. So 0, 1, 0, 0. Okay, so you have to activate the 4 and then the rest are deactivated. Right? So again, you can just simply remove this 0 right here. It will not affect your answer. So just simply write 100. Okay. So that's how we've got 100 on 4 ones. Okay. Adding 4 1. All right, so are we clear so far on how did we get 10, 11, and then 100?
Yes, sir. Okay naman.
Okay, so let's have an example. So just let me know if you guys are confused so that, oops, we can go over with it and then talk about it again. All right, so let's try to answer this one. So is there anyone who wants to answer this one with me? I guess not. All right, so I'll just answer this one by myself. So 1 plus 1 is 10. So carry 1, bring down 0. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 plus 1 is 11. So carry 1, bring down 1. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 plus 1 is 11. Carry 1, bring down 1. 1 plus 1 is 10. So carry 1, bring down 0. And then since we don't have any number right here, just bring down that 1. So the answer of this one is 10, 10, 100. Were you guys able to follow?
Yes, sir. Yes, sir.
Yes, sir.
All right. So let's see if we've got the correct answer. No, so 10, 10, 100. So 10, 10, 100. All right, so that's how we've got those results. All right, so let's move on with the next example. So number 1 is already answered, which is kind of similar with number 2. So I will not answer number 2 anymore since this one is quite easy anyway. So we will just answer number 3. All right, so anyone who wants to volunteer who would like to answer this one with me? Number 3. Oops. Anyone? All right, so I guess none. Anyway, so 0 plus 1 plus 0 is 1. 1 plus 1 plus 1 is 11. Okay. 1 plus 1 plus 1 is 11. So carry 1, bring down 1. 1 plus 1 plus 1 plus 1 is 100. Okay, so bring down 0 right here. Then how do we put the carry 10? Anyone who knows where to put the our carry? All right, so this is how you do it. So put here the 1 and then put here the 0. So just one character at a time, okay, or one value at a time. So you cannot put 10 on one character only. So it should be on the other character. Okay. Then after that, you may now proceed to the next one, which is 0 plus 1 plus 1 is 10. So carry 1, bring down 0. So 1 plus 1 plus 1 is 11. So carry 1, bring down 1. 1 plus 1 plus 1 plus 1 is again 100. So carry 1, oops, yeah, carry 1, carry 0, and then bring down 0 right here. So it's 100. 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 plus 1 is 11. So carry 1, bring down 1. And then 1 plus 1 plus 1 plus 1 is 100. So carry 1, carry 0, bring down 0. 0 plus 1 is 1. 1 plus 1 is 10. Carry 1, bring down 0. And then bring down 1. All right, so that's how we've got this result. Or this is the result of number 3. So were you guys able to follow so far?
Yes, sir.
All right, so again, the
Yes, sir.
only, yes? Okay, so the only difference of number 3 and 1 and 2 is the 4 ones. Okay, so in here we have 4 ones where you have to carry the 1 and 0 on each character. Okay, you cannot carry the entire 10 on one character, right? So for the number 4, I'll leave this one to you guys now as we're a practice activity. Okay, so make sure to answer this one. Sorry, I forgot to put the decimal. So just put here the decimal. All right. Okay then, so that is for the addition or binary addition. Okay. The next one is binary subtraction. So in here, 1 minus 1 is of course 0. Let me just get this one. So in here, 1 minus 0 is of course 1. 0 minus 0 is of course 0. And 1 minus 1 is of course 0. However, we have this one, 0 minus 1 is 11. Okay, so I will show you guys later on how we've got 11. Okay, so I know that this one is quite weird, but in binary, so this is how it works. Okay, so let's have this example. So 1 minus 1 is 0. 0 minus 1 is cannot be. So we have to borrow on this neighbor of yours. So this 1 will become 0, of course, but this 0 will become 10. All right? And then this 10 is, of course, being represented by binary. And if you're going to convert this one into decimal, this one is actually 2. All right? And then this one, 0, 1, or this one only, could be 1 only. So those are being represented by 1. All right? So 10 minus 1 is 1, or 2 minus 1 is 1. All right? So 10 minus 1 is not 9, okay? In here, 10 minus 1 is 1. So are we clear with this one so far?
Yes, sir.
Okay. And then again, we have here 0 minus 1 is cannot be, so we have to borrow on your neighbor. So this 1 will become 0. 0 will become 10. 10 minus 1 is 1. 0 minus 0 is 0. 1 minus 1 is 0. And 1 minus 0 is 1. So we have here 10, 0, 1, 10. 10, 0, 1, 10. All right? So that's how we compute a binary subtraction. Okay? So the only trick part here is this one. This 10 right here. And then 10 minus 1 is 1. Anyway, let's have more example for you to be able to understand what is binary subtraction. So for the number 1, it is already answered, or it already has an answer. So I will leave this one to you guys now. And then I will just answer number 4, okay, for now. And then I'll leave the number 3 and number 2 to you guys. So from here, we have 0 minus 1. This cannot be. So we have to borrow, okay? So this one will become 0. And then this 0 will become 10. Okay? 10 minus 1 is 1. 0 minus 1 is cannot be. So we have to borrow again. But then again, the number right here that supposedly that we're going to borrow with is not available or doesn't have anything, okay? So this guy should borrow to its neighbor for us to be able to borrow from him. So this 1 will become 0, and then this 10 will become 10. So now that he now has a value, okay, or a money, let's say money, then that's time we can now borrow from him. So this 10 will become 1, and then this 0 will become 10. So see, once you borrow, you'll get 2, okay, you'll not get 1. And then this 10 can now be subtracted by 1. So 10 minus 1 is 1. 1 minus 1 is 0. 0 minus 1 is cannot be, so we have to borrow again. But then his neighbor, of course, should borrow to his neighbor for us to be able to borrow from him. So 1 will become 0. 0 will become 10. And then now he now has a money, then we can now start borrowing from him. So 10 will become 1. 0 will become 10. So 10 minus 1 is 1. That right here. 1 minus 0 is 1. And then 0 minus 1 is cannot be, so we have to borrow again. Then again, this 1 doesn't have a money, so he should borrow first to his neighbor. So 1 will become 0. 10 will become 0 will become 10. And then 10 now will become 1. And then this 0 will become 10. So 10 minus 1 is 1. 1 minus 0 is 1. 0 minus 1 is cannot be, so we have to borrow again. Okay, but then again, this one doesn't have anything, so we have to borrow on his neighbor. So 1 will become 0. 0 will become 10. And then since he has now a many, then we can now borrow. So 10 now right here will become 1. And then this 0 right here will become 10. 10 minus 1 is 1. 1 minus 1 is 0. 0 minus 1 is cannot be, so we have to borrow. So, but then again, this one doesn't have anything, so he has to borrow first his neighbor. And then this, of course, 1 will become 0. 0 will become 10. And then he now has a money, then we can now borrow. So 10 will become 1. 0 will become 10. 10 minus 1 is 1. Minus 1 is 0. And then 1 minus 0 is 1. So there you go. This is the result of example number 4. So, were you guys able to follow? Or it's quite confusing since we have a messy solution. But that's how you do it. Okay, cancel 10, 0 will become 10, 10 will become 1, etc., etc. Hello guys. Were you guys able to follow with our example number 4? Okay, so with this one, what you really need to do is, do it on your own. You should experience it on your own. So that is why we have here the number 2 as in doesn't have any answer. So you should answer this one. And then you should also answer number, what is, so we have already answered number 4. So you should also answer number 3. Okay, so 2 and 3 will serve as your practice exercise. Okay, and you can send me a message wherein if you want me to check your solution. So yeah, you can do it. Okay, so send it via Canvas or via Facebook. All right, so that's it for the binary subtraction. The next one here is octal addition, wherein for the letter A, so no problem, it's the same with our addition. 2 plus 3 is 5, 1 plus 5 is 6, so nothing special. But in letter B, 1 plus 7 is supposedly 8, right? But then right here, 1 plus 7 is 10. So how did that happen? Okay, so if you guys can still recall, okay, we have this decimal. We have this decimal to octal, okay, wherein 0 to 7 is the same with octal, still 0 to 7. Okay, so this is a direct conversion from decimal to octal. But once we've reached, let's say, 8 to 15, in here, we're going to have 10 to, 8 to 15. We're going to have 10 to 17. Okay. Now, why did we get 10 right here, but why not 8, why not 9, and then just 8, natural way? That's because in octal, okay, octal is only ranging from 0 to 7, okay? Or in other words, this one doesn't have 8 and 9, okay? And then the next one right here is, of course, 10 to 17. This one doesn't have 18 and 19. Of course, the next one is 20 to 27. Again, this one doesn't have 28 and 29. Okay, so as you guys can see, we have already missed 8 and 9. So we have 2 numbers in total for the 0 to 7. So that is why you have to add it up on the next one. Okay, or just simply jump to 10. Okay, if you don't want to, keep on adding by 2, by 4, by 6. So in here, you have to jump straight to 10. So 0 to 7, 10 to 17, 20 to 27, 30 to 37, 40 to 47, and so on and so forth. So that's how we count an octal. right? For the decimal, it's still the same. So 0 to 7 or 0 to infinity. So it's increasing by 1. Okay. So the next one right here is 16 to 23. In here, it's already 20 to 24. 20, 23 plus 4, 20 to 27. All right. So for the first one, okay, so 10 to 17, it's plus 2 from the decimal. Okay, as you guys can see, the result right here is just plus 2 on the octal. 8 became 10, so it's just plus 2. 15 became 17. So if you have 13 here, it will become 15 on octal. But right here, 2027, we have here a plus 4. That's because we have already missing 18, 19, and then 8 and 9. So it's a total of 4. So 2 plus 2 is 4. Right? So once you breach 28 to 29 or 20 to 27, 28, 24. 24 to 31. This one here is 31. In here, it's already plus 6. So it's 30 to 38. Okay. So right here, it's plus 6. However, this one is already a quite large of data when it comes to addition or subtraction. So mostly, we are only reaching up to 23. 0 to 23 or 0 to 27. Okay. So you guys don't need to worry. Is it plus 2? Is it plus 4? Is it plus 6? Is it plus 8, plus 10, plus 12? And so on and so forth. So, okay, so that's the pattern when it comes to decimal to octal. So that is why in here, 7 plus 1 is 8 in decimal, but in octal it's 10. Okay, right here. That is why we have here carry 1, bring down 0. 3 plus 2 plus 1 is 6. Base 8. So are we clear so far regarding with octal addition? Hello guys? You guys still there?
Yes, sir.
Okay, so I hope that you guys were able to get this one. So yeah, that's how we convert decimal to octal. All right then, so if everything is clear on this example, then let us try to answer letter C. All right, so in here, it is asking us to add 6.7 base 8 to 45.6 base 8 plus. All right, so 6 plus 7 is 13. And if we're going to take a look in this one, it is between 8 to 15. Then 8 to 15 is directly converted to 10 to 17, wherein it's only plus 2. So 6 plus 7 is 13, plus 2 on octal will become 15, of course. So carry 1, bring down 5. 5 plus 6 plus 1 is 12. So it's still between 8 to 15, so it's still plus 2. So this 12 right here will become 14. Carry 1, bring down 4. 4 plus 1 is 5. And then decimal right here, base 8. So the answer right here is 54.5 base 8. So were you guys able to follow this example? Hello?
Yes, sir.
Yes, sir.
All right. So just let me know if you guys are confused in some parts so we can go over with that one again. All right, so I will leave letter D and E as your practice activity. So make sure to answer those, and then if you're not sure with your answer, so just message me. You just show me your answer and then how did you do it, then so that I can guide you. Okay. And then we have here hexadecimal addition, wherein if we have octal, we also have hexadecimal, wherein in octal we don't have 8 and 9, but in hexadecimal we have everything. Okay, it is actually complete, but you must follow the correct sequence. Okay, so right here, right, so I guess we don't need paint for now. So 4 plus 6 is 10, right? And then as you guys may all know, in hexadecimal, 10 is 8. So just put here 8. 2 plus 7 is 9. So very simple. The answer right here is 9, 8. And in here we have 7 plus 9 is 16. But then again, it's not 16. It's actually 10. Now, how did we get this 10? So let me just get this one. All right. So let's have this decimal to octal conversion once again. Decimal to hexadecimal conversion. So 0 to 9 is the same with hexadecimal. Okay, but then once we reach 10 to 15, in here it's already the one that we are calling A to F. All right, so can you guys still recall this one? 0 to 9, 10 to 15, and then 10 to 15 is A to F. Guys, naalala niyo pa ba to?
Yes, sir.
And then right here, for the 16 to 25, so how did I know that this one will end up to 25? So just follow the pattern. So for the first 9 numbers, I mean, 9 bawat 10. 16, 16, 17, 18, 19, 20, 21, 22. Yeah. So plus 9. Okay? Kasi kasama na yung 1 dito sa 16 as your starting point. So 16 to 25 or 16 plus 9 is 25. And then right here, you will start with 10. Okay? 10 to 19. So in here, plus 9. In here, plus 9 also. So 10 plus 9 is 19. So if you're going to take a look at this one, we actually have a pattern wherein we have 0 to 9, 10 to 19. The next one is 20 to 29. Okay, and then letters again. So the next with 25 is 26 to 31. Okay, so this one right here now is 1A. Okay, 1A to 1F. 1A, 6, 2, 7, 8, 9, 10, 11. Yeah, so 26 to 31. And then right here, it's 1A to 1F. Just to differentiate the A right here. So of course, the next one will become 2A, the next one will become 3A, 4A, 5A, and so on and so forth. Okay. So let's just say that this is the number that we're needing for now. Wherein 7 plus 9 is 16. So it's 10 in direct conversion in hexadecimal. So carry 1, bring down 0. And then F plus E plus 1. So if you're going to convert F, it's actually 15 in hexadecimal. I mean in decimal. And then E is 14. Okay. And then we have here plus 1. So just add everything and then you will get 30. So just look for 30 in here, wherein 30 is between 26 to 31. So just less 1, wherein before 1F is of course 1E right here. So in hexadecimal, 30 is 1E. So just simply write here 1E. So that's how it got